Okay, let's quickly go over this quiz.
Hey, wait.
Now, depending on which quiz you had, obviously you had a different answer. The problem was the same though, the general problem. It says the following. A projectile is fired from ground level, and its path through the air is modeled by the following function. So here's what I think right away. I think about a projectile being fired, it's shot off, and then it comes back down. It does not have to be symmetric. It could be over here. Okay, it could be over here, depending on which equation you have. Now, first part says, find the coordinate of the projectile when it's at its maximum height. What's another word for that we're looking for? The vertex, that's the word. Very good. So, I'm looking for either this location, or this location, or this location, depending on which of these curves I'm on here. Again, depending on which problem you had, it will look different. But the first part says you have to be able to turn words into math terms. Again, find the coordinate. Oh, too much talking. Find the coordinate. Coordinate means x and y value. If I had wanted the axis symmetry, I would have said find a horizontal location when the projectile is at. Guys, I'm not going to keep doing this. Stop. Find the coordinate of the vertex here. So we are not only looking for x, we are also looking for y. So you are looking for these two values here. If the problem had said find the horizontal location when the projectile is at a max height, horizontal location means the x value. That would be talking about the axis of symmetry. Okay, again, if it says find the horizontal location when the projectile is at its max height or at the vertex, that's the axis. But it just said find the coordinate. Specifically, the word coordinate means x and y value. So the first part, find vertex.
Weren't they all different?
They're all different equations, but all the words were the same. So your problem is the same gist, but each problem is a different equation. Find the height of the projectile when its horizontal value is 0. What does that mean? Okay, put 0 for x, which is finding what? The y-intercept. Again, if you put 0 for x, you got it, that's fine, but you got to know what it's actually asking for. When the horizontal value is 0, it means you're on the x-axis, on the y-axis here. It's when x equals 0 right here. So you're looking for the y-intercept. Depending on which function you had, it would have been a different location. If you had a function that was symmetric, then the vertex and the y-intercept are like the same thing. They are the same thing actually here. Again, if this was symmetric, this top path right here, then your y-intercept and your vertex are actually the exact same thing. Now, again, you have to be able to take these words and turn them into thoughts and ideas in math. This is like when we went over the example with the person punting the football and the other person that was shooting a basketball. Okay, the same idea. One of the problems said like find the location or find the height of the ball when it hits the backboard. That was the y-intercept. Another part of the problem said find the location when it's at the top of its path. That was also the vertex again. You have to be going over your notes before the weekend. Again, I mentioned this the other day in 3rd and 2nd period class. When you guys don't have homework over the weekend, or if you're done with your work, you need to also review last week's work, and I don't see that happening enough. Okay, whenever I was in, just leave right there. Whenever I was in school, I would always make sure that on Sunday nights, even if I spent just a quick half hour, I went through like 10 minutes of math, 10 minutes of social studies, 10 minutes of English, just looking at the previous week's worth of work. It will help you a lot. Okay, it will help you focus when you're going into the next class. So that today, when you come in here, you're not wondering, okay, what is it on? What did we do last week? What are we doing here? Now, obviously, if you do your homework, it gets the same point across. Okay, so doing your homework helps as well. Continuing with that, so doing your homework. The second part, let's take a look at homework. Are there questions? Because some of you said you had questions already, and that's fine. I know we did not finish concept 22, which is understandable. But you were not supposed to do 7 and 8, if you remember. You did not have to do those two. Looking on the, you need a worksheet? Looking on the front side only. Look on the front side only. Tell me if there are any questions on the front side.
Yeah.
As long as you're ready to take it today, yes. You're welcome to take it. Make sure you're in.
But if we want to go tomorrow, do we just put like Tuesday or something?
Yeah, that's fine. Vicky, come by, the work can get it. Okay. It's also on deadline already, but I have extra copies down there. It's probably over in 208 or 209 already. Hold on, Juliet and John.
The first one.
Okay, the first problem. So we're looking at the homework now. We're pulling up the first problem from concept 22. This one right here?
Yeah.
Okay. Can somebody help us with the first one, please?
Oh, I just going to
You sell it?
use that factoring thing?
Yeah, but it's already factored, right?
Like x plus 10 equals 0 and
Good.
x minus 3 equals 0.
This one was not meant to trick you guys. If it's in factored form already, just make a t-chart and find the roots. Again, find the x-intercepts. X-intercepts are the roots or the zeros of the function. Whenever it's already factored, start by just making a t-chart and then you get your answer. Your answers are going to be -10 and +3. Okay? Again, we didn't go over this one, guys. We didn't even go over it if it's given like this because what did we do in the beginning yesterday or Thursday? We said let's factor or let's use AC method to factor. Either way, when we factored, we ended up making a t-chart. So if it's already factored, you don't have any work left to do. Just make a t-chart and solve. Okay?
It's because you're always tricking us. So we make something super easy. We're like, oh no, something else. It's you. Wait, I was next.
John was next. M&S.
5.
Number 5.
Oh, yeah, that one's different.
Number 5. Okay, what are you going to do for number 5? Raise your hand. Somebody help us out here. Somebody besides Gisela this time. Ashley. Well, you can tell me. Let's try.
Okay, I added 3y on both sides.
I agree. And then what did you do?
And then I got 28y to the second power plus 3y.
Y to the second power plus 3y, yes.
And then I subtracted 28 on both sides.
Now, why did you do all this? Please tell me.
Because if I subtracted y on the y to both sides, it would be negative y. So I wouldn't find like there would be no, it wouldn't make sense.
It would, but it would be a very tough way to factor. So that's I agree absolutely with what you did. So again, here's what she did. First, Ashley said, if I want to find the roots or the x-intercepts or the zeros of the function or the solution to the equation, I need to get a 0 on one side. That's where our goal is always to get a 0 on this side. Even if we go back up to the last example, when we had y equals those two factors, we should really start by putting a 0 for y. Because we're finding x-intercepts, thus we set y to 0. Now, in this case, we're finding the solution to the equation. As Ashley had said, if she moved the y squared over here, she would have ended up with a negative y squared minus 3y plus 28. Again, if she moved the y squared over, this is what it would have looked like. Now, there's no problem with that at all, actually, because what you can do is divide everything by -1, and you get back down to this line, actually. Divide this by -1, divide this by -1. Just switch all the signs. Now, in this case, it's actually the same amount of work because it took her 2 steps to move those over, and it takes 2 steps to do that also. So it doesn't matter, but in the end, I agree with Ashley. We want this to be positive. It makes it a lot easier. If it's negative, you can still do it, but then you would have a factor of negative y plus something and positive y plus something, which is a little bit different from what we had seen. So I agree. I would always put it back in standard form. We're still on this problem. You can always, always, always use the quadratic formula, absolutely. But you have to be in the correct form. This is standard form. Or this is actually also standard form. It doesn't matter. But Julia, you have to get into this form to use the quadratic formula. You've got to get a 0 on one side. We talked about this with concept, concept 17, 18, or 19, I forget which one. The one, 17. where we use the calculator to find the x-intercepts? Remember we talked about how you have to have a 0 on one side to do that? Well, that's what this is. We're getting a 0 on this side. We're getting a 0 on this side. Doesn't matter which spot. Do it. What we did over here you're talking about? And then you use A is -1, B is -3, C is 28. That works fine. Again, Julia, the only problem is you got to get a 0 on one side. But if you're going to factor, guys, if you're going to factor, you probably want a positive y squared. It makes it a lot easier to factor. To factor this one up here, you're going to have a negative y here. And then you're going to have a positive y over here, which will get a little bit confusing for some people. So I recommend doing it this way. It's easy, though, once you do this. What do you get here?
+7 minus 4.
Very good. +7 minus 4. Okay, so your answer should have been -7 and +4. Again, should have been -7, do the opposite of these, and +4. John? We're still on number 5, John. Are there questions on number 5? Okay. Vanessa, you have the next question.
Number 4.
Number 4.
Oh, yeah.
Number 4. What do you got to do here, guys? C could be 0, and you can use the quadratic formula, sure, but that's so much more work than you have to do.
Can't you just grab it?
You could always grab it, but it's not going to help you sometimes. Remember the first technique was factor, and then the second technique was factor with AC method, and then the third technique was quadratic formula?
Sure.
Well, the first technique of factoring can be used here. What's the GCF? 3 what?
3x.
3x. There's an x in both. Put a 0 equals 3x squared minus 3x. Okay? Again, all you need to do here is factor out the GCF. Once you've done that, you can already make a t-chart. Whenever you don't have a C value, factor out a GCF. Please write this down. I don't see anybody writing it. When you don't have a C value, factor out the GCF. When C equals 0, or when you don't have a C value, factor out the GCF.
Be quiet.
Yeah, I put mine in the calculator.
Wow. It's meant for a calculator. Derek knows how to use a calculator.
You didn't know how to use it.
You're going to need to be able to do it by hand, though, so keep that in mind. Make sure you practice by hand. Guys, calculators are great resources, and we're going to go through a program of that today or tomorrow. But make sure you know how to do the stuff by hand as well. John. John, we're still on number 4. Are there any further questions? I'll ask for another question in a minute.
Well, number 3.
Oh, we're on number 4 still.
Oh my god.
Any questions on number 4?
No.
Okay, so this is clear, right?
Yeah.
Again, when there's no C value, when there's like a +0 over here, when C doesn't exist, use the GCF. Okay, now, number 3. Number 3, I would absolutely recommend using the AC method. What's your question, John?
I did the GCF and on the left side, I got D equals 4 and 5. But for the right side, I didn't know where to. It was 3 times 5 minus 4, but I didn't know how to go on from there. Should I just 5 minus 4?
Why don't we just go through it, John, and we can show you that because other people are waiting to see it instead of jumping to the last line. Okay? I understand, but other people are waiting. 15 times 8 is good. 120, and we have a negative there. Very good. The B value is -2. Now, before giving an answer, we have to think about what's going on here. What numbers multiply to -120? Okay, we're just thinking. We're not giving answers yet. And add up to -2. Again, This is a tough one simply because the number is negative 120. Now, I know many of you know the answer. Hold on for a sec so I can show the method in case you don't know. Again, remember, we need to figure out numbers that multiply to this. The simplest thing to always start with is 120 and negative 1, or negative 120 and 1. But those clearly do not add up to negative 2. Okay, they have to add up to this value. These do not. This adds up to 119. This one adds up to negative 119. So I can try 60 and 2 next. But is 60 and 2 going to work?
No.
Because 60 and 2 is going to give me like a 58, right? And I know 58 is not going to work. So if I try negative 60 and 2 or negative 2 and 60, they both don't work, I know already. So I want to start eliminating choices. I can try 30 and 4 or 40 and 3 or negative 4 and 30. Okay? But those are also not going to work. Okay, Derek, you really don't want to do that when I ask you to wait. So here, again, we can try 30 or 40 and 3 or 30 and 4 or the reverse of that with negatives in other spots, but clearly that's not going to work. So you can also try a 5 in here. You can try a lot of numbers. We can try the 15 and the 8, but they're all not going to work until we get to the last possible choice, which, Derek, here's your chance. What is it?
Negative 10 and 12.
Thank you, Derek. You threw that voice pretty well. Negative 10 and 12
Negative 12 and
or negative 12 and 10. Now, out of those two possible choices, we're going to see that only the negative 12 and 10 works because we want them to add up to a negative number. So we're going to use negative 12 and we're going to use 10 here. Now, just by looking at the setup of this problem, I would have chosen to use either the quadratic formula or I would have graphed it to look for the roots, just because I have all this work that I need to do here. Okay? And again, the quadratic formula will give you the roots, and if you want to know what the factors are, just put it back into factor form. But now that we know these are the actual numbers we're looking for, let's break up the problem. 15 t squared minus 12t plus 10t minus 8. Now, please remember, it does not matter if I switch these two. You get the same answer, and you better get the same answer. Because the math doesn't make sense if not.
You said so aggressive.
You better get the same.
You have to, though. Think logically, right? Addition is commutative, which means you can add them together in either direction. Thus, if I switch those two, it better not change my answer. If it does, you're making a mistake somewhere. Now, here, I need a GCF of those bracketed values. So the first value, somebody tell me the first value.
3t.
A 3 for sure and a t. Again, that's a 3t. Now, as of right now, I really don't care what's left, because I know what's in the parentheses is going to be the same. So I can factor out the second part and see what I get here. What's my GCF on the right side, everybody? 2. Again, look at this. There's no t in both, but these are both even. So factor out a 2. Now, whatever's in the parentheses must be the same. Remembering the following. If you forget how to figure out what's in the parentheses, divide the side by the GCF. Divide this by 2, divide this by 2. What do you get when the first part here?
5t.
What's 8 divided by 2?
Negative 4.
So, what should I get over here?
5t minus negative.
And take a look. Divide by 3t. Divide by 3t. You're going to get 5t minus 4. So, back to John's question in the very beginning, we have our factors now. One of which is the repeated value in the parentheses. The other of which is the coefficients. So 3t plus 2, again, that comes from here and here. That's one of my factors.
5. And then 5t minus 4.
Very good, girls. 5t minus 4.
So, Mr. Howe,
Yes.
for the one on the left side, it's always going to be the
coefficients or the GCS, absolutely.
And the one on the right side is the one that...
You don't have to say right or left, just say one of the factors, because does it matter which order they're in, John?
No.
Multiplication is commutative, again. Okay?
Did you get what I'm saying?
Of course, but say one of them and the other, yes, absolutely. Now, here's the hard part about this, guys. Had you used the quadratic, you would know, you're paying attention. Had you used the quadratic formula, you would have got exact answers. You wouldn't have got factors, which makes this a lot tougher to get the factors. So when it says factor the following expression, you really do have to use your AC method or you have to use your regular factoring method. Okay? Again, remembering that because it's hard to get these. If you use the quadratic formula, you would have gotten 0.8 as one root and negative 0.666 as the other root, which doesn't really tell me too much about this right here. Again, how come that comes about? Because if you solve these and you set them each equal to 0, that's what you're getting with the quadratic. You get negative 0.6 repeating over here, and over here, you're going to get t equals 0.8. So if you got these values, these are the roots, but they don't tell you too much about the factors in this case. That's the hard part. Okay, so if you're asked to factor, you pretty much do have to use factoring techniques.
I used AC method and I got those two at the bottom.
This and this?
Yeah.
Because you can did use AC method, you got to here and then you probably continued.
Yeah.
Yeah.
But what does the problem say?
Factor.
So do you have to go any further?
Oh no.
Again, that's the difference about our words here, guys. It's important. This problem says factor. So you stop right here. If it said find the roots, then you continue down to here.
So
What I'm trying to show you is this. Down here is what you would get if you use the quadratic. You would get these two answers right here. But we don't need them this time because it doesn't say find the x-intercepts. It says factor the expression. Okay?
yeah.
Everybody understand what's going on here?
So the answer is 3.
The answer is 3t plus 2, 5t minus 4. Okay? On the back page, let's keep going.
Number 6. Number 6, I got up to the first
You don't
one.
need number 6. You just showed me you had it right. What are you asking about?
No, because I did like over 2, but then I'm not sure the answer I got was right.
No.
Okay, number 6. What kind of a shape is it?
Right.
What's the area of a triangle?
A.
1/2 base times height or base times height over 2. Brandon, you need to turn this way, please. Okay? Go sit on the other side with Daniel so you can see the board. Thank you. So here we have area equals base times height over 2 or 1/2 base times height. Now, I know the area. I know the base. I know the height. Okay? It's a quadratic because you're going to have to FOIL it out and solve. So here, how do I get rid of something that's dividing by 2? Multiply, or just take the 2 and bring it up over here. Okay, remember, you can always take something in the denominator of one side and bring it up to the numerator of the other side. So what's 2 times 115? 230. Be careful. Okay, now on the next line, what should I do to solve this? What do I need on one side of the equation? 0. So I have to distribute over here and then move the 230 over. So 230 equals 10, again I'm distributing this 2x to both of these. 10x squared minus 4x, and I have a 230. What should I do with the 230?
Move it.
Move it over. So subtract it. Again, remember, whenever you move something over to the other side of the equation, just switch the sign. You don't actually have to think about subtraction. If you're going to move it over the whole term, just switch the sign. Please. And you can simplify ahead of time or you can simplify now because everything is even. See that? So factor out at least a 2. You can't factor out a 4 though. Where'd you pull out a 2?
When it was 5x minus 2, I got 10x squared minus 4x, and then I divided by 2.
Absolutely. I would do the same thing. Yep. Here, take a look. There's a 2 in everything. So you can factor this into 2 as 5x squared minus 2x minus 115 equals 0. Again, I'm taking this equation and pulling out a 2. Does that 2 have any effect on the problem?
No.
Why? How do I get rid of the 2 in the very front? Divide, right? Okay. So if I divide this side by 2, what happens to the 2's?
It cancels out.
If I divide this side by 2, what is it still?
0.
So does it really matter?
No.
Again, when you factor out a constant, please write this. When you factor out a constant, not a variable, but a constant, you can simply drop it off. Again, when you factor out a constant, just drop it off. Again, whenever we're setting equal to 0 here, remember this is the scenario we're in. The constant that comes out can just drop off. Now I'm left with an AC method problem that is a little bit easier than the previous one. Now, at this point in time, I'm looking for the value of x. I don't care about the factors. So you know what? I wouldn't even use AC method. I would either graph it and find the x-intercepts, or I would use the quadratic formula here. Again, graph it and find the x-intercepts, or use the quadratic formula here. Please, you don't actually need to go through the process of AC method. It's more time than you actually want to waste. So if you have to factor like the last problem, then sure, you have to use AC method. But this says find the value of x, which is saying find the x-intercepts, or find the roots of the equation, or the solution to this equation. So, using this method to find the solution, can somebody tell me what we get here? Anybody get this far to get the actual quadratic formula down? Thanks. The actual solutions when you use when you either use AC method and make a t-chart, or use the quadratic. Plus or minus, sorry, ahead. All over. 10, obviously, thank you, because it's 2, 5. Again, at this point in time, if you want to get numerical values, break it up into 2 components, one being plus, one being minus, and you get your 2 answers here. But this is our exact form. This is 2304 underneath the radical here, in case you can't see. Okay, I'm assuming Luis is right. If anybody disagrees, please let me know. That's fine. We all make mistakes, so it could be wrong, so check this. That's a 0, by the way, right there. Okay. Now, for this type of a problem, again, we're looking for a dimension x, so it might be worthwhile to actually find the exact values here. Again, it may be worthwhile to find the exact values here, because we're trying to figure out what x represents, which is a dimension of a triangle. Okay? Questions on this one beyond that? Okay, 7 and 8 you didn't have to do. Let's go down to the last one, or last 2. Is there 1 or 2? Okay, no, very good. If you guys tried number 9, the AC method will not work. Okay, it's one of those cases. If you use the quadratic, besides Vanessa, because I know she knows already, did anybody notice something funky about their answer? Did anybody actually try this, honestly? Okay. When you got to a certain point in time, under the radical, what did you get? You get a negative. You got a negative under the radical. Okay. So you're going to get a negative underneath your radical. The number is going to be negative 68, it looks like, under the radical. Now, we didn't even go into that yet, so you can't go any further. Today's lesson, which is 23, we're not going to get to it today. It's fine. We're going to run out of some time. We'll go tomorrow. But we're going to talk about what it means when our roots are imaginary. Okay? And it's a very, very important lesson. And we're going to talk about more of that tomorrow. Okay, but keep that in mind. So once you use the quadratic here, you will get a negative under radical, which means it's imaginary. So we have to stop there for today. We can't say anything more for that part. Okay? We'll talk more about that. The last one. What do you have to do for the last one, guys? Same side. Good. Get one side equal to 0. Again, as always, when you're solving an equation that is something that's higher than linear, so it's x squared or x cubed, you want to get a 0 on one side. So once you get the 0 on one side, what can you then use?
Quadratic.
Good, quadratic formula. Now, here's what I would do. I would do it all in one step when you're moving stuff over. Okay? I would subtract the x squared from both sides and add the 7x all at one time. So 4x squared minus 1x squared
3x squared
plus the 7x
plus 3.
plus the 3, and this side has to be a 0 over here. Again, remember, whenever you move something over to the other side, just switch the sign. So everybody see how it was a negative 7x on the right side, and now on the left side it's a positive 7x? Just switch the sign. Okay? Now, if you had just switched the sign for the x squared, you have to realize that you have like terms, and these like terms can be combined to this final number. Now, at this point, either AC method or quadratic formula. We don't know if it'll work. We'd have to try it. AC would be 9. B would be 7. Are there two numbers that multiply to 9 and add up to 7? There are not, so we can't use AC method, thus quadratic formula. Again, quickly, here's your AC method check. AC is 9 in this case, and this one is 7. Are there any numbers that multiply to 9 and add up to 7?
Nope.
3 and 3 doesn't work. 1 and 9 doesn't work. You're done. AC method doesn't work. So go to quadratic formula. Again, x equals negative b plus or minus the square root b squared minus 4ac. And then remember, all over 2a. Remember, all over 2a. That's the hard part there, the thing to remember. Other questions on this?
No.
No?
No.
Okay, what else do we have outlined for today?
You made us stop. Finish that note. You made us stop. Mickey wants to go to song.
Mickey wants to know the
Mickey
song.
wants to go to song.
All your classes know something.
No, we don't know it.
Oh, you sorry?
Dang it. I know,
Sorry.
I was telling her the song, right? She's like, is that the thing?
Do it
Sounds
like you. Stop talking, Pete.
No violence.
Now,
Don't rhyme here.
the second part of 22, we have 12 minutes. We can get through this easily. The second part of 22 is if you're given a problem in vertex form, how to find the roots. Okay? So again, remember, last class on Thursday, we looked at standard form with factoring or with the quadratic formula. Again, we did factoring or we did the quadratic formula with standard form. Now, let's look at vertex form. If you have the notes printed already, I might use a different example here, just so you know, so don't let it confuse you. So here, we have an equation. Let's say the equation says okay, there's our equation right here. And let's not use 3 twice. I don't want to confuse people. Let's use
6.
Sure, 6 works for me. Okay, so let's say this is our equation or this is our function. Now, with this kind of a problem, we don't have A, we don't have B, we don't have C. It's not in standard form. So we're not going to factor or use quadratic formula. You can put it in standard form by FOILing out the x minus 3 and then distributing the 6. But you know what? That technique is not worth your time. This problem is a lot easier actually than it looks. If I want the x-intercept or the root, what must I always do? Set y to 0. You heard that too, right? You said Jesus. It was very holy. Now, once we remember to find the x-intercept, we set y to 0. At this point, it's like any other equation. Okay? It's like any other equation. So, x is not going to be 3 here. Because if we put a 3 in, this drops off, but you still have a negative 4 equals 0, which is not true. Okay? So here, let's not guess what it is. Let's just solve the equation. How do I get rid of whatever I need to get rid of first? What do I need to get rid of? Okay. I can't divide by 6. I have to get rid of the 4 first. So, here's what we do. Add 4 to both sides. Guys, focus. Come on. Okay. Now, once I get the 4 over, I need to get rid of the 6. How do I get rid of it?
Divide by 6.
Good. Divide by 6 now. 4 over 6 is 2/3 or 0.6 repeating. Okay, I'm going to leave it as 0.6 with a bar over it. Now, the goal is to get x. I can't get x until I get rid of that square. And I can't get x until I get rid of that 3. Which one do I do first?
The square.
The square. Very good. How do I get rid of a square, everybody? Square root, both sides. When you square root, how many answers do you get?
2.
That's what's so important. Because remember the quadratic formula is plus or minus? That's where the two answers come from. So remember we always talked about how when you take a square root, you have to get plus or minus. Again, plus or minus is extremely important because you have two roots to this equation. Two roots. How do I get rid of the 3, everybody? Add 3, right? Add 3. Now, when I add 3 to this value, I want to make it look like it's in, make it look like it's in the form that we get when we get the quadratic formula. So if I have an added 3, I want to write it as 3 plus or minus the square root of 0.6. And those are my two roots. Again, this process is not difficult math, but to remember what you're doing, you have to think about how to solve this equation. Okay? Now, you're not always going to need the bar. Thank you. I'll put it over there now. Only because it's a repeating decimal. Thank you, Derek. If we want to think about this as standard as our standard equation with no numbers, just variables, let's go through this. So here, if I have, yes. This is my standard form. Leave her alone. This is my standard form over here. If I want to solve analytically, first of all, what does it mean when I say I want to solve analytically or generically?
Solving without numbers.
Solving without numbers. Whenever I say solve analytically or solve generically, we are not going to plug numbers in. Now, in order to find the x-intercept, though, we need to have a 0 for y. So here, I guess technically we're going to put a number only in there, though. Okay, keep that in mind. You can't do this process unless there's a 0 there. Okay, step me through it, John.
Alright. Minus k.
Good. Subtract k from both sides.
Subtract 8, so I can divide 8.
Divide by a on both sides. Okay, this is what we got so far. So again, if we're solving just with variables, we've subtracted k and divided by a. Julia, focus please. John, continue.
And then you'll have the square root of negative k.
Good. Take the square root as the next step. Very good. So when we square root this side, we're going to get negative k over a with a plus or minus equals x minus h. And finally, John, what should I do with the h? Add the h to both sides. So just put the h right in front over here. Again, put the h. Whoa. Put the h right in front. Why is that happening? Right in front over there. Okay? Put the h right in front in this spot right here. So we're going to get add h, h plus or minus the square root of negative k over a equals x. Now, let's think for a second. We don't know k. We don't know a. We're going to have some situation we have to consider here. If a and k are both positive, what does this turn out to be under here? A negative, which is? Imaginary. So a and k, if a and k are ever both positive, you will always have an imaginary root. And we're going to talk a lot about this tomorrow, and how it's going to look when we graph stuff. So again, remember, if a and k are both positive, you have an imaginary root. If a and k are both negative, you still have an imaginary root. Because the negatives cancel. If a and k are both negative, they cancel. You're still left with this negative right in front. Now, if a and k are both negative, those negatives cancel, you're still left with this negative. So it still is imaginary. The only time we're going to get real roots when we use the vertex form is if a and k are opposite signs. So if a is negative, and k is positive, you end up with a negative over a negative, which cancels. If k is negative and a is positive, you get a negative up top, which is a positive over a positive. So keep in mind, if k and a are greater than 0, or if k and A are less than 0, you end up with imaginary answers. And we'll talk about what to do with imaginary roots tomorrow. But if the signs of K and A are the same, your roots will be imaginary. Julia. This was where we're going to move H into. We said add H to both sides and place H right in front. That's where it came in front. Okay? Now, for tonight, you have 2 other problems, number 7 and 8. Okay, number 7 and 8. Please get to those. Work on both of them. Okay? You could have tried them, and that's fine. You're welcome to. You always are. Okay, but 7 and 8 is your homework. Tomorrow, expect a quiz on this. You've got 3 minutes. You can probably get both those homework problems done already.
Solve the equation.
Wait,